In this video lecture I will discuss about the helium neon gas laser, its principle, construction and working. Myself Dr. Sushil Kumar, and the first point is about the introduction of the helium neon gas laser. It was invented by Javan Bennett and Herriot in 1961. Helium neon laser is a 4-level laser. Its usual operation wavelength is 632.8 nanometer in the red portion of the visible spectrum. It operates in continuous working mode. So as you know that any laser have 3 major components. One is the medium, that what laser medium is used to construct the laser. Here in helium neon gas laser, you know that is the helium and neon gas mixture. Second point comes about the pumping process, that what type of pumping is used to populate the energy levels, that is here atom inelastic collision. And third point comes about the resonator cavity, in which all these process basically runs, that is the assembling of the 2 mirrors, right? One is perfectly reflector and second one is the partial reflector. So here first of all I will discuss about the energy levels, that how transition basically take place in between the energy levels, and especially for the 4 energy levels, which is the main component of helium neon gas laser. And second point is about the population inversion. So you see here there are 4 energy levels. This is the ground, lowest one is the ground state, the upper one is the excited state, and this level is represented by E2, and there are number of atoms N2. In ground state, that is the level E1, energy level E1, and there are N1 are the number of atoms. And third point comes about this energy level, that is represented by E3, and there are N3 number of the atoms. And about the fourth energy level, that is represented by E4, and the number of atoms into this particular energy level are N4. So in addition to this basic information, we know the ground state is the lowest state of the atom, and this is the excited state of the atom. In between of the ground state and the excited state, all the states are known as metastable states. So the next one is about the metastable state. The lifetime of the metastable state is higher as compared to the ground state. So here you know that this is the excited state, and the lifetime of the excited state is about 10 raised power minus 8 seconds. And the lifetime for the metastable state is about 10 raised power minus 3 seconds. So you see that the difference between the excited state and the metastable is about 5 times, right? So metastable state have lifetime 10 raised power minus 3 seconds, and here for the excited state, that is about 10 raised power minus 8 seconds, right? So now about the metastable state, the lifetime here is 10 raised power minus 3 seconds. So now the question about fast transition or slow transition. Fast transition, you know that the lifetime is very small. This is 10 raised power minus 8 seconds as compared to the metastable state, that is about 10 raised power minus 3 seconds. So you can imagine that the atoms which lies into the excited state immediately jumps into the this particular state. So the transition will be fast as compared to the transition from this state to this particular one state, that is the E4, because lifetime is longer as compared to the excited state. So most of the atom will stay here longer as compared to the excited state, and because of that this transition will be slower. This transition will be slow. So all the atoms immediately jump into this particular state. Transition is fast or slow? Transition will be fast. Atoms stay here longer, right? So that transition will be slow or fast? That transition will be slow. And how I am telling that this transition is slow or fast? On the basis of time, this lifetime of the state. Here the lifetime is about 10 raised power minus 3 seconds. So this is the lifetime, and on that basis one can say about the fast transition and slow transition, right? So now the population inversion is achieved in between these two states, right? As you know that in general the number of atoms are more into ground state, right? N1 is greater than N2 or any other number of the in any energy levels. So N1 is greater than N2 or any other states, N2 or N3 or N4, whatever the energy levels are available. We are talking here about the 4 energy levels. So in all the cases N1 will be larger as compared to the other number of the atoms, but this situation is in general condition, right? So in general the maximum number of the atoms will be in ground state and minimum number will be into the excited state, right? And in this particular situation, when population inversion is achieved, then that time population inversion is achieved where? In between the metastable state and the excited state and the ground state. In which state? This one and this one. In these two, population inversion is achieved. You know that the lifetime of this state is longer as compared to the excited state. So all the atoms basically starts to accumulate here in the during the process, and in the ground state, in this the number of atoms will be smaller as compared to this one. So this particular situation is known as the population inversion, means large number of atoms into the excited state compared to the ground state, means population has been inverted as compared to the general case. So this situation is favorable for the stimulated emission process, and through that you get the laser light. So from this energy level, that is correspond to the E3 and N3, and this one is the E4 and N4 are responsible for the laser light. So you will get the radiative laser transition from these two energy levels where you have observed this population inversion here, right? So the transition will be slow. First thing, the transition will be radiative transition. You know that all the atoms which jump from the excited state here comes into this particular metastable state, not always jumps into the ground state by stimulated emission process. Some of them also jumps spontaneously, and the photon which emits basically due to the spontaneous emission process can induce the other atoms which are into the excited states, and because of that the excited atom now will emit two photons of the same frequency and into the same direction, right? So now the two photons which emits because of the stimulated emission process will be of same frequency and in same direction, right? Direction is same, frequency is same, and because of the frequency, you know, nu is equal to C upon lambda. If frequency is same, that means there is only one wavelength, and that wavelength represents to a particular color. So this is one of the point, that frequency is same, phase is same. So because of that you say that laser light is monochromatic and unidirectional, because all the photons are emitting into a same direction, right? So one photon which emits from the spontaneous gas is responsible to induce the other excited atoms, and then after the other photons can induce the other excited atoms of the metastable state, and this is the reason, this is the cause of laser light, right? So here in this process stimulated emission dominates over the spontaneous case. This energy level E4 is very close to the ground state, right? And so here you see that this is known as the non-radiative transition and fast transition. It means all the atoms which accumulate here after the transition of photon immediately jumps into the ground state. Here this is the ground state, because they jumps into the ground state by collision with the walls in which they are kept, right? So that is the non-radiative transition. So in the next slide we will see the procedure construction, some points about it. The setup basically consists of a discharge tube of length 80 cm and bore diameter of the discharge tube around 1.5 cm. It can vary basically from 50 cm to 80 cm, or diameter from 0.5 cm to 1.5 cm, and the gain medium of the laser, as suggested by its name, is a mixture of helium and neon gases with the ratio of 5 to 1 to up to the 20 to 1, where 5 represents the helium atoms and 1 represents the neon atom, right? So this 5 here, this ratio is the ratio of helium and neon atom. It can vary up to the 20 to 1. Here 20 is for the helium atoms and 1 is for the neon atom. And as you know that neon is responsible for the laser light in case of the helium neon gas laser. So all these basically are kept into the electric discharge tube. The length and the diameter is mentioned here, right? The energy or pump source of the laser is provided by an electrical discharge of around 1000 volts through an anode and cathode at each end of the glass tube. The optical cavity of the laser typically consists of a plane high reflecting mirror at one end of the laser tube and a concave output coupler mirror, right? A mirror of approximately 1% transmission at the other end. Helium neon laser optical output power range vary from 1 milliwatt to the 100 milliwatt. Right, so the main part is the lasing medium, second is the pumping process, and third about the resonator cavity. In now by this block diagram I will try to explain how basically it works. So in laser light comes from 3s to 2p orbital transitions of the electron, and that output is of the order of 6328 angstrom. 1 angstrom is equal to the 10 raised power minus 10 meter. So what happens initially? Initially one electron, basically accelerated electron, strike with the helium atom and excite it into this way, right? So first of all we excite the helium atoms, and then after this excited helium atom collide with the ground state of neon atom, and because of that this collision of the excited helium atom, neon atom comes into their metastable state, right? Ratio we have discussed earlier, that is the 10 to 1, where 10 is for the helium atoms and 1 is for the neon atoms. These are two mirrors. This is the completely reflector. This mirror is a mirror. This is perfectly reflector. This one is the second mirror, right? Mirror B. This is partially reflector. Here blue color indicate to the neon atom, and this red color ball indicate to the helium atom, right? So initially in beginning what happens? This helium atom strike with the neon atom, and as a result they transfer their energy to the neon atom, and neon atoms right now is into the excited state. When the neon atom comes into the ground state, it basically emits the photon, and that photon basically run parallel to the axis of the glass tube, and as a result of multiple reflections, right, when the cavity filled up, then the photons come out from this tube, and as a result you observe this laser light. So this is the for discharge purpose red color, and high potential, as we have discussed earlier, that is of the order of 1000 volt. When this voltage is applied to the system, electron basically accelerate in between this, and you know that helium and neon both are inert gases, and it is very difficult to excite neon in that particular metastable state directly, so we use indirectly this way of the helium. First of all we excite the helium atom in excited state by the collision of electron. That electron comes from the cathode, right, and they strike with this helium atom as shown here by this reaction. In terms of the energy level we discuss in the next slide, and then after this excited helium atom collide with the ground state neon atom, and because of this now this helium atom transfer their energy to the neon atom, and neon atom now is into their excited state. But which energy states are responsible for the laser light? They are 3s and 2p orbitals, in which we get the laser light, that is 6328 angstrom, so red color light. So here with this energy level diagram you can understand better that earlier, first of all, this is the ground state of helium atom, right? So we provide electric discharge method. So by this way helium atom excite into two different states. One is correspond to the triplet state, and second is correspond to the singlet state. what do you mean by triplet and singlet state? Basically, in helium, if you see, there are two electrons. These orientation of these electrons inside the atom may be parallel or anti-parallel. If this is parallel, then you know that spin angular momentum for one electron is plus 1 by 2 in upward direction and minus 1 by 2 in downward direction. So plus 1 by 2 and plus 1 by 2 in upward direction is equal to, that is 1. So because of that, we find multiplicity. Multiplicity is defined by 2s plus 1, and when we put the value of s, that is equal to 1 here. So 2s plus 1 becomes 3. So multiplicity if is 3, we call it triplet state. And this is the total angular momentum, spin angular momentum, that is 1. Right, so this is the name of the state by using the multiplicity 2s plus 1. And what about this singlet? And the second possibility of these two electrons in excited state of the helium might be, one is upward and second is downward. So plus 1 by 2 and this is minus 1 by 2. So the total result of spin angular momentum will be 0. Right, one is plus 1 by 2 and for downward that is minus 1 by 2. So plus 1 by 2 and minus 1 by 2. Plus 1 by 2 that is for the upward, and minus 1 by 2 is for the downward electron. So total result is equal to sum of these two. Spin angular momentum will be equal to 0. This is equal to 0. So s is equal to 0 when you will put this value here in multiplicity formula, that is 2s plus 1, s is equal to 0. So this will be equal to 1. Right, and total spin angular momentum is 0. So here you see that this is 1, that is coming from the multiplicity, and this is 0, that is total angular momentum. So this is singlet state and this one is the triplet state. The energy of these two different states of helium atom is near about 18 point something. Right, 18.6 electron volt. And for the singlet, that is about 20.61 electron volt. Here you see this is the 20.61 electron volt. This energy is just near about to the metastable state of the neon atom, that is about 20.66 electron volt. So by this way one use this helium atom to excite the neon atom. So now 20.61 electron volt is the excitation energy of helium atom. Rest of the 0.05 electron volt energy, the difference between these two energy is 0.05 electron volt. From where this energy comes? Because this is 20.61 electron volt and this is 20.66 electron volt. So this 0.05 electron volt energy comes from the collision, from the right, this helium atom is excited in excited state and it is vibrating, so that have basically in addition to this one, 20.61 electron volt, 0.05 electron volt is the kinetic energy of the excited helium atom. So the total energy becomes 20.66 electron volt, and this is the metastable state of the neon atom, right? So 3s, because of this energy 20.66 electron volt, when transferred to the neon atom, here this is the neon atom. So when this 20.66 electron volt is total energy from the helium side, this excitation energy and this kinetic energy 0.05 electron volt transferred to the neon atom, and neon atom comes into this particular state, that is the metastable state of the neon atom, is known as 3s, where 3 is the cell and s is the orbital. So correspond to the singlet, we get this 3s or 3s state, that is the metastable state of the neon atom, and correspond to the triplet we get the 2s state of the neon atom, which is about 18.6 electron volt, right? So now the point is about the laser light. So now we got that 3s is the metastable state of the neon atom, and now neon atom will come into the ground state. There are two possibilities. First of all, for this state 3s, one is this one transition into the 3p, and second possibility is into the 2p, right? So this 3p is near about to the 3s, and the wavelength basically which we observe from the transition of the electron between these two states, and in terms of the photon, that is 3.39 micrometer in the range of infrared radiation. Second point is about transition between 3s and 2p, in between these two, that is basically 6328 angstrom, and this is the laser light, right? So here the metastable state is 3s and the second state is 2p, and then from here the atoms, after the transition of photon of this particular wavelength, comes into the ground state, that is the 1s state. This 1s star basically, it means that this state, right now this state is ground state, 1s state, but is a little bit higher from the actual ground state. So how the atoms basically now come into the actual ground state in this one, that is the diffusion with the walls, right? So atoms basically when comes into this state, they lose their energy with the collision with the wall, right? And as a result comes into the actual ground state. So here you know that the helium neon gas laser is of 4 energy levels. So 3 energy levels of the neon atom, 1, 2, and you consider it 3, because it is near about to the ground state, and the atoms, neon atom, lose that energy, the difference between the actual ground state and this particular 1s star, by diffusion with the wall. So these are the 3 energy levels of the neon atom, and one is of the helium atom, this upper one, that is correspond to the singlet. So these 4 energy levels play the role in helium neon gas laser. And which orbitals are important, in which you see the transition? They are 3s and 2p energy levels. 3s is the metastable state of the neon atoms, this one, and 2p is the lower state. And from here you will obtain the fast radiative transition. It means the transition will take place spontaneously from 2p to the 1s star. This transition will be spontaneous, right? So that transition will be fast and it will be radiative transition. So this is the energy level diagram of the helium neon gas laser. I have just focus only on the two different state of the helium on the basis of spin angular momentum, that is the singlet and triplet. Singlet is responsible to excite the neon atoms. Total excitation energy in case of metastable state of the neon is 20.66 electron volt, and here the excitation energy of the singlet is 20.61 electron volt. Rest of the energy comes from the kinetic energy of the excited helium atoms, right? So the usage of the helium neon gas laser are: number 1, this is the narrow red beam of helium neon laser is used in supermarkets to read barcodes. Number 2, the helium neon laser is used in holography in producing the 3D image of the objects. Number 3, application of the helium neon gas laser have many industrial and scientific uses and are often used in laboratory demonstration of optics. Thanks for watching this video. If this discussion is helpful to you, then please like and subscribe this video channel. Thanks once again.